Good afternoon, all. I belong from company Siemens. We provide control center automation solutions for distribution network as well as transmission networks. And the paper is also about that only how we can support a distribution operator when we are talking a lot about bidirectional power flow in distribution networks as renewable energy penetrates more and more. So in the presentation, I will just cover up these things. What is the current scenario? What is the current scenario in distribution network in India? And what would be the upcoming challenges in distribution network as we have more and more distribution, as we have more and more renewable energy sources. Then what is the role of distribution system state estimator with that? To run the distribution state estimator, what is the importance of your generation and load modeling? Then we have something called as active network management, which works on the output of your distribution system state estimator, which is to support operator. And how we can effectively alert operator by making some visualization to alert him. We have some coloring effects that helps him understanding what is the volatility in the system and if he can avoid it or not. And a small part where future generation management, we have some scope in distribution network as well. So the current monitoring in distribution network, if I talk about some cities where the control center is already available, say under RAP DRP schemes, there we have P, Q and V telemetries that is available in control center in SCADA. So this is the conventional SCADA we have in some of the cities in Maharashtra as well as Uttarakhand, to name. And we have some challenges now as we have the increasing penetration of renewable energy, renewable generations. I will not talk more on that. We have been hearing since two days about that. The main concern is that we have to make this renewable generation flexible, and that results in frequently changes from 0 to rated power of that renewable generation, and that is going to create bidirectional power flows. That is very clear now. From the distribution operator, that results in unclear power flow directions, and he may not be able to see what is the volatility going to happen. So how we can counter attack it? Like we propose to use distribution state estimator with correct load and generation modeling, and if the volatility exists, if that can be overcome by some means, by activating some controls or not, and that we will cover under active network manager. So what is distribution state estimator? It's a part of a distribution management system at a distribution control center which runs 24/7. That can be activated on some events like some topology changes or some changes in P or Q, significant changes in P and Q, or it can be run periodically as well. So what it actually does is it provides you active power, reactive power, voltages and current quantities in all parts of your networks. As you know, this distribution network may not cover 100% telemetry. So where the telemetry is not available, the distribution state estimator has to give this estimated quantities in untelemetered areas as well. This is the first thing what distribution state estimator does as a primary function. Depending upon the output of your distribution state estimator, there are some checks whether there are some violations occurring in the system. Based on that, the secondary information is given to the distribution operator as a bigger picture so that the attention can be drawn for the operator on the correct things. It can cover like alarms. In alarms, the critical network states which may require some attention from the operator. It can include some trippings. It can include some voltage violations. And then it can, distribution state estimator also give you a monitoring on what are the exchanges with your transmission system, mainly on P and Q values. So basically, DSAC will have input as P, Q, I, V measurements at substations. Looking at the Indian scenario, we mostly we have telemetries at a level of 33 by 11 kV, and the network below that substation is not mostly telemetered in the current scenario. And then the second input that has to be given is a load and generation models, because we don't have that telemetry to the lower ends. What algorithm it follows is it will have the measurement islands, mostly consisting of a measurement. We can split it into multiple islands. The estimation is actually bringing your P and Q more closer to the measured values. So the estimation problem is mathematically defined as minimization of one function that we will follow in upcoming slides. The main concern is here the pseudo P and Q measurements at loads and load groups, which comes generally from the schedules, where the consumer end, where we do not have the telemetries, we are mainly dependent upon some schedules that has to come from some sort of depositories. And we also have some current and voltage magnitude measurements, which we also can use in distribution state estimator. So if you look at here,
that doesn't work properly.
No.
You don't see anything.
So if you look at the highlighted parts, the one measurement. Yeah. Okay. So talking about this MA2, I have a measurement here, V0, P0. So till the next measurement comes, this part I can contribute it to one measurement island. And my aim is to, with distribution state estimator, to have the quantities P, Q, I, V in this network, which agrees to these measurements. So what output is supposed to give is detailed current, voltage, power information for every single element in the network. If there are some violations in the system pertaining to voltage and thermal limits, and the power losses, active and reactive power losses. So for load and generation modeling, talking about the load at the present, load data sources are generally these values, pseudo values are coming from, the schedules are coming from accounting data. Then maybe load classifications like residential, commercial, and their load curves. These data, we can say that this is not accurate data. The other source can be AMR, automated meter readings, and AMIs. However, these are the correct, accurate enough, but this comes little late into your system. So it can be with a delay of 15 minutes, we can say. To overcome this, we generally modify the load curves continuously in the system with the help of short-term load scheduler. It works with negative feedback with the DSAC. So DSAC is distribution system state estimator. So if you look at here, So DSAC will always give inputs to your STLS so that it can adapt as per your DSAC output. So over the time, STLS is expected to give the load curves which are more accurate and which are more close to your real-time world. So this is the graph where scheduled adapted load, it is being adapted to the actual world. I will just skip this. And I would like to emphasize here on generation scheduler. The conventionally generation schedulers were actually treated as load modeling as. So the need of the hour is, with increasing of your number of renewable sources, the static curve what we have been using may not be helpful. Hence, the integration of your forecast generation, that data should be incorporated into your generation scheduler. This is required to give better results for your DSSC output. Once the DSSC is successfully run, then operator is aware of his network state, and he can also see what are the volatilities existing in his system. So next thing is whether he is able to resolve them with available controls or not. So active network manager, what it does is actually simulates the network to remove this volatility. And the main part of this is volt var control. VVC supports the NM. It calculates and simulates all the required control sections to achieve the given objective function. And that objective function, the primary objective function is to minimize the violation, and it can be combined with other objective function as to minimize the active power losses, to reduce the active power consumption or reactive power consumption. So, but the basic objective function is going to be the minimizing violations in the system. That is to countermeasure volatilities. What we propose here to present this in in a visual presentation that operator can immediately have a look at. Here we present one objective function as ZTOT, which will give you significance of the existing limits reached, the loadings reached, and also the reserves used by the system. So if you look F limits, F limits represents your violations in your lines. Loading represents your loadings in your transformer, overloading your transformers. FR represents your use reserves, and FPF is the penalty for your power factors. So this is one algorithm. So in first step, the operator will see if the algorithm will see if the ZTOT is greater than some parameter. If it exists, then it has to say that yes, it is existing and exceeding, and it has to be simulated with the NM simulation. And with this, if operator is able to bring the ZTOT below some particular level, then the signal will be given as a LO. The semaphore will turn into LO, so that operator can be assured that with some control actions which is in his hand, he can control this volatilities. If no, it will be turned as a red, and he has to take some actions like load curtailment. So there could be other options as well, but he has to take actions correctly immediately. And in first stage only, if we find that there is no violation, it will turn into green, so that operator can be assured it works fine. So this is this semaphore concept can be applied to the feeder level as well, so that operator gets a bigger view. And at the detail view, we can, if operator finds some red signals, yellow signals, he can go to the detail view and he can find which are the equipments that are getting violated. Talking about the future generation, recently we heard that you must have heard yesterday that Dadri has tested closed loop AGC. That was implemented by us. We have provided some customized solution to POSOCO. Now with this we think of providing some optimization for conventional and renewable sources in distribution network as well. And what generation management can do is just present here. I will not spell it out here. That's it from my side. Thank you.
Thanks for your presentation. Questions?
Thank you. I thought I'd save my voice instead of shouting there. Alan Gidding, Smarter Grid Solutions. I guess my first thought here is, your very first slide, you talked about how the RE can ramp up and ramp down very fast within a period. But then what struck me is that throughout all this process, whether it's the load forecast, whether it's the generation forecast, whether it's the estimation process, whether it's the asynchronous nature of the data you're pulling back from the SCADA system, every one of those is adding error into the system when the renewables is constantly also varying. So I guess, how do you calculate the error that you have in your signal and what you're presenting at the end of it, and how does the operator who's looking at the result trust what's actually in front of them?
So it differs from case to case. Where every case when we go, we have to fine tune it. Like what is the confidence you have in your static data, and what is the confidence you have in your telemetries. So according to that, we have to verify that. It's not always a uniform case in every case. But still, so I accept that there are some challenges. Yes.
Further questions? So then I have a small question. So you were presenting your distribution state estimator. So it goes maybe in a similar way. So to come to acceptable fault or errors, let's say, within the state estimation. Right. So how many measurement sensors do you have to integrate? And did you make there some case studies on that?
The case study was made by our development team in Germany, so I have not included those here. So what we did, we have some standard system where we test all this. It's almost 60 buses, where we try to run the research related topics on that network. So we have that standard network.
Maybe I can.
Yep.
Maybe I can comment. We have a smart grid concept called INES. You know also about that in Germany, and they also do a state estimation, however, on the low voltage level mainly. And they're saying like 10 to 15% of the buses they have to actually like measure in order to get a good value in terms of state estimation. So I don't know what was whether it's comparable, just to give a number. Yeah.